Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 18 video on the topic of sinking and floating of a solid in a liquid from the chapter of Physical Quantities and Measurements, where I will solve the set 2 problems, 5 problems, multiple choice questions. These questions are based on the concepts and formulas that I discussed in the video of part 12, 14, 15 and 16. Also, I have solved in the previous video set 1 5 problems. So if you have missed that, then also please do watch that video. So this video is part of the playlist ICSE Physics for Class 8, where I primarily discuss key concepts and formulas related to numerical problem solving. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 18 video of set 2 problem solving, set 2 of 5 multiple choice question based on the sinking and floating of a solid in a liquid. Okay, so the first problem says that the ratio of, one second friend, I forgot to configure, set up the canvas properly. That is the software where I am writing. It is not working properly at the moment. Please give me a few seconds. Okay, so the first problem says, so the first problem says the ratio of the densities of two bodies A and B is 1:m, where m is greater than 1. Okay, the body B floats in water at 4 degrees centigrade, fully immersed, and experiences a buoyant force of P gram force. Okay, then which of the following statements is or correct if body A is immersed in water at 4 degrees centigrade? Oh, okay. The body B floats in water at 4 degrees centigrade, fully immersed, and experiences a buoyant force of P P gram force. Okay, let's try to visualize what is happening. So in both the cases, the liquid is water at 4 degrees centigrade. So let's say this is body A. Body B is floating in water at 4 degrees centigrade. So in both the cases, rho 2, that is the density of the liquid, is equals to 1. If I consider it is 1 gram per centimeter cube. So rho 2 in both the cases is water at 4 degrees centigrade. So rho 2 is 1. Now regarding body B, it is said that the body B floats in water at 4 degrees centigrade, fully immersed. Okay, so this is the scenario. It is fully immersed and experiences a buoyant force of P GF, means gram force. Okay, now fine, and let's say the density of the body B be rho B. Now we have to, it is asking that which of the following statement is or correct if body A is immersed in water at 4 degrees centigrade. It sinks, it floats fully immersed, it floats with P by M centimeter cube volume of immersed part, it floats with P into M centimeter cube volume of immersed part. Okay, so basically we have to first find out the densities of the bodies A and B. Let's say for the time being, body A is partially body A is, let's say it is floating, uh, it is floating in the water, uh, partially immersed. So, this body A is having a density, let's say Pa. Okay. Now, what is given? The ratio of the densities of the two bodies A and B is 1:m. So, we are having rho A by rho B is equal to 1 by m. Now, it is given that m is greater than 1. If m is greater than 1, okay. Now, so this implies rho B is m into rho A. Now, since it is given m is greater than 1, so we can clearly see that rho B will be greater than rho A. Rho B will be greater than rho A. Okay, so B is the denser, if the density of B is greater than density of A. Okay, let's see what is happening with the body B. It is floating, fully immersed. Now we know that a body floats in a liquid fully immersed when the density of the body is equal to the density of the liquid. So clearly we can see that rho B has to be equal to the density of the water at 4 degrees centigrade, which is equal to 1. So rho B is equal to 1, that is 1 gram per centimeter cube. Okay. So we can say that rho B is nothing but m gram per centimeter cube, because rho A, we have rho B is equal to m into rho A. So we have got rho B equals to 1. So rho A is equal to rho B by m. Rho B is 1. So this is 1 by m. And since m is number greater than 1, clearly 1 by m is a number which will be less than 1. So rho A is less than 1. Rho A is less than 1. Rho A is less than 1. And rho 2, which is water at 4 degrees centigrade, is 1. So we can clearly see that rho A is less than rho 2. So in the body A, the density of the the density of the body A is less than the density of the water at 4 degrees centigrade, which means that the body A will definitely float partially immersed in the water. Okay. So clearly we can reject choice A because the body A will not definitely sink. Choice B is saying it floats fully immersed. No, the body A will float in the liquid in the water at 4 degrees centigrade fully immersed only when the density of the body A will be equal to the density of water at 4 degrees centigrade, which means that rho A has to be equal to 1. But we got that rho A is less than 1. So B is also not correct. Now choice C is saying it floats with P by M centimeter cube volume of immersed part. Let's see. We know that when the body of a density of a body is less than the density of a liquid, the body floats in the liquid partially immersed, and the fraction of the body which is immersed, fraction of the body which is immersed, let the fraction be F. That fraction of the body which is immersed in the water will be the density of the body divided by the density of the liquid. So for the for the body A, it will be rho A by rho 2. Okay. Now what is rho A? Rho A is, from the right hand side we got rho B by rho A is 1 by m. So this is 1 by m divided by, what is rho 2? Rho 2 is 1. So this is 1 by m. So 1 by mth part of the body A will be immersed in the water. Okay. Uh, how do we know how do we know the volume? It is given, it is choice C and D is saying it floats with P by M centimeter cube volume of immersed part. We know that the fraction of the body A immersed in the liquid is 1 by M. But to know exactly the volume of the immersed part, we need to know the volume of the body A. How do we know the volume of the body A? It is given that the body B floats in water at 40% fully immersed and experiences a buoyant force of PGF. PGF, nothing. I think there is a problem. I think it should have been given that the volume of both the body A and B are same. Only then we can find the actual volume of the immersed part of the body A. Let's see what we get from the fact that the body B experiences a buoyant force of PGF. Now, since the body B is fully immersed and it is floating, we will have, if we consider the volume of the body B, to be V, let's say volume of the body B be VB. So, definitely the volume of the displaced liquid in case of the body B will also be VB since it is fully immersed, and the mass of the displaced liquid will be VB into rho 2, this much gram. And of course, so the force, the buoyant force will be equal to the weight of the displaced liquid. So it will be VB rho 2 gram force, which is given to be capital P gram force. So I can say VB into rho 2 should be equal to P. Since rho 2 in this case is 1, because the liquid is water at 4 degrees centigrade, I get VB is equal to P. So the volume of the body is P. We are getting clearly that the volume of the body is P. So I think I'm really sorry, in this question it should have been mentioned that both the body A and B are having the same volume. In that case only we will have VA is equal to VB is equal to P, and this implies, since if the fraction of the part of the body A which is immersed in the water is 1 by M, this implies the volume of that is V dash. By V dash I always denote V dash to be the volume of the immersed part of the solid in a liquid. So for the body A, V dash will be VA, its fractional part multiplied by VA. F is 1 by M and VA is P. So this is P by M, this much centimeter cube. So the correct choice is choice C, but the question should have mentioned that both the bodies A and B are having the same volume. Okay, let's see the next problem. The next problem says a body having a density of rho 1 gram per centimeter cube floats in a liquid of density rho 2 gram per centimeter cube such that its mth part, where m is less than 1, which definitely means that m is a fraction, that is a proper fraction, such that its mth part of its body is above the liquid surface. Okay, so okay, if volume of body is VML and if B is the buoyant force, then which of the following choices are correct? Let's quickly visualize the situation. So this is the body floating. The density of the liquid is rho 2, okay, and the density of the body is rho 1, okay, and it is given that if I consider V dash to be the volume of the immersed part of the body, V dash, then, and it is given that the total volume of the body is VML. I know that the fractional part, the part of the the part of the body immersed in the liquid, I mean, what fraction of the body is immersed in a liquid when it floats in a liquid partially immersed, that is nothing but V dash by V. We have already discussed that this is nothing but rho 1 by rho 2, okay, and what is and what exactly is V dash by V? Okay, now this is the fractional part of the body immersed in the liquid. Now in the problem it has given that mth part of the body is above the liquid surface. So if m and m is obviously a proper fraction, that is m is less than 1. So I can say that what will be the what fractional part of the body is below the liquid surface. That is actually V dash by V, and from the fact that mth part of the body is above the liquid surface, I can say that 1 minus m is the fractional part of the body below the liquid surface. So I can say V dash by V is equal to 1 minus m. Okay. Okay. So this implies, okay. So I get V dash by V is 1 by m, is 1 minus m. Also I know V dash by V is rho 1 by rho 2. So I have rho 1 by rho 2 is equal to 1 minus m, and this implies that rho 1 is equal to rho 2 into 1 minus m. So from this fact, clearly I can reject the choice. I can reject the choice B, because in choice B it is given rho 2 is equal to 1 minus m rho 1. I can reject choice B. I can also reject choice. I can also reject choice C. I can also reject choice D. From the in choice C and D it is given rho 1 is equal to m rho 2, and in choice D it is given rho 2 equals to m rho 1. So definitely the correct choice has to be rho A. Now we actually didn't find out what will be V. Let's, even though we have correctly chosen we have correctly solved the problem, we have correctly selected the correct choice, but let's anyway, for the sake of discussion, let's see what will be V. Okay. Now it is given that the body experiences a buoyant force of Fb. Okay. Now what is Fb buoyant force? It is the weight of the displaced liquid, and the weight of the displaced liquid is nothing but its mass gram force. What is the mass of the displaced liquid? Its volume into density. Volume is V dash and density is rho 2. And what is V dash? What is okay, we have Fb equals to V dash rho 2. Fine. Now from here we can see we get sorry, V dash is equal to Fb by rho 2. V dash is equal to Fb by rho 2. Also we know V dash by V is equal to 1 minus m. This implies V dash is Fb by 2. Fb by 2. This by V is equal to 1 minus m. So this implies that V is equal to Fb V is equal to Fb by twice 1 minus m. Fb by twice 1 minus m. But in the choice it is given Fb by rho 1. Why Fb by rho 1? And V is equal to Fb Fb by rho 1. The buoyant force no, the buoyant force will be equal to the weight of the displaced liquid, and if V dash is the volume of the displaced liquid, I mean V dash is the volume of the immersed part of the liquid, so V dash is also the volume of the displaced liquid. So the mass of the displaced liquid will be V dash rho 2, V dash rho 2, and the weight of the displaced liquid will be V dash rho 2 gram force, which is given to be Fb. So we can say that Fb is equal to V dash rho 2. So this from here we can clearly getting V dash is equal to Fb by rho 2. Okay. Buoyant force, oh, okay. So V dash is Fb by rho 2. That is fine. Okay. Now, since the body is floating, anyway, we will have the buoyant force is equal to the weight of the body. And what is the weight of the body? It's mass gram force. So what is the mass of the body? Is volume, which is given as VML, V rho 1. And rho 1 is the density of the body. So clearly from here we can see that V is equal to Fb by rho 1. So V is equal to Fb by rho 1. Also V is equal to Fb by twice 1 minus m. This is fine. This is what it is given in the choice A. So choice A statement is correct. But we also got V equals to Fb by 2 into 1 minus m. Is this true? Is this correct? If Fb equals to V dash rho 2, fine. V dash is equal to Fb by rho 2, fine. So we are putting in the equation V dash by V equals to 1 minus m. We are getting V dash is Fb by rho 2. Oh, V dash is Fb by rho 2. I am doing silly mistake. So this is Fb by rho 2. So now this implies is equal to 1 minus m. So this implies V will be equal to Fb by rho 2 multiplied by 1 minus n, and rho 2 multiplied by 1 minus m is also equal to rho 1. Okay. Let's see the next problem. Question number 3. Two bodies of same substance but having masses m gram and 2m gram floats in the same liquid with 1 by mth part where m is greater than 1 and 1 by nth part where n is greater than 1 of its body immersed in the liquid respectively. There are two bodies, they are of same substance, meaning the two bodies are having same density, but one is having mass m gram and the other is having twice the mass, that is 2m gram, and they are floating in the same liquid. Okay, and in the first case 1 by mth part is immersed, and in the second case 1 by nth part is immersed. So basically 1 by, since m is greater than 1 and n is also greater than 1, so 1 by m is nothing but the fractional part of the body which is immersed. 1 by m is the fractional part of the first body having mass m gram, which is immersed in the liquid while it is floating. Also 1 by n is the fractional part of the second body having mass twice m, which is immersed in the liquid. Okay, then which of the choices below is are correct if the experienced buoyant forces are F1 gram force and F2 gram force? Okay, so it is also given that the buoyant forces they are experiencing the first body is experiencing a buoyant force of F1 gram force and the second body is experiencing a buoyant force of F2 gram force. Okay. So, and both the body are floating. Two bodies of same substance but having the masses this and this floats. Okay, so both the body are floating in the same liquid. Okay. Okay. In the first scenario, let's say this is the case. In both the cases, the liquid is same. Let's say the density of the liquid be rho 2, and in both the cases, both the bodies are of same substance. That is, both the bodies will have density same. Let's say the density of the substance is rho 1. Okay. Let's try to visualize the scenario. Okay. So this is floating. It is given that the buoyant force for the first body is F1. Okay. And okay, and 1 by mth part of the body is immersed in the liquid. So for the first body, I can say that 1 by m is equal to rho 1 by rho 2, because we know that when a solid body of density rho 1 is floating either partially or wholly inside in a liquid of density rho 2, then the fractional part of the body of the solid body which is immersed in the liquid is rho 1 by rho 2. Okay. For the second case, and of course, what is the weight in the first body? What is the weight? The weight is equal to the sorry, the weight will be the mass. The weight is given. The mass is given as m gram. So the weight will be for the first body m gram force. So I'm just writing m. For the second scenario, the body is floating. The buoyant force is given to be F2 gram force. The density of the body will be rho 1 only, because both the bodies are of same substance and they are immersed in the same liquid. So the density of the liquid is rho 2, and for this body the weight will be twice m, that is twice m gram force. Okay. This is the scenario. So for the second body, since it is floating, I will have and since it is given 1 by nth part of the body is immersed in the liquid, I will have 1 by n is equal to rho 1 by rho 2. Okay. So clearly we can see that 1 by m is equal to rho 1 by rho 2. Also 1 by n is equal to rho 1 by rho 2. So we can clearly say that 1 by m is equal to 1 by n. This means if we do cross multiplication, m is equal to n. M is equal to n. So at this point we can clearly reject the choice A and B, because in choice A it is given n is twice m, n equals to twice m, and in choice B it is given twice n is equal to m. Now let's see, we have to choose, the correct choice will be between C and D. Let's see what we can say about F1 and F2. Now in both the cases the body is floating, which means that the buoyant force will be equal to the weight of the body. So clearly we will have F1 is equal to, for the first case, m, and for the second body we will have F2 is equal to twice m. So F1 is equal to m and F2 is equal to twice m. So what we can say? Okay, so from this we can clearly see that F2 is equal to twice m and F1 is equal to m. So I can say F2 is equal to twice of F1. F2 is equal to twice of F1. So clearly the correct choice is C. C is the correct choice. C is the correct choice because F2 is equal to twice m, but in choice D it is given that F2 is equal to m. No, F2 is equal to twice F1 and F2 is equal to twice m. So the correct choice is C. Okay, let's see the next problem. Okay, for the question 4 and 5, while I was framing the question, I was so tired that I could not properly describe the problem. So it's a visual problem. Let me explain. In question number 4, basically it is three figures are given where the body is same. The body is same. That is, the body is having a density. The same body is floating in different liquids, and the different liquids are having densities rho 1, rho 2, and rho 3, and the body is exactly the same. So the body is having densities rho. Now you have to select the correct choice of the ordering of rho 1, rho 2, and rho 3. How do we know? How can we compare rho 1, rho 2, and rho 3 when we know that the body immersed is the same body, that is same mass and same density? Clearly we have to we can identify that based on the fraction of the volume, the fraction depending on how much part of the body is immersed in the liquid. From there we can do a comparison of the rho 1, rho 2, and rho 3. How? We know for the first case that let's say for the first figure, the fraction of the part of the body which is immersed in the liquid be F1. For the second case, let the fraction be F2, and in the third case, let the fraction be F3. Okay. Now, clearly, visually, we can clearly see that F3 is less than F4 is less than F4. Sorry, F3 is less than F2 and F2 is less than F1. In the first figure, the greatest part in the first figure, the maximum amount of the body is immersed. In the second figure, the part of the body immersed is second largest, and in the third figure, the part of the body immersed is the smallest. So I can say F3 is less than F2 is less than F1. Okay. Now what exactly is F3? F3 is nothing but rho by rho 3. This is less than what is F2? F2 is rho by rho 2. Similarly, this is less than what is F1? F1 is rho by rho 1. So we are having rho by rho 3 is less than rho by rho 2 is less than rho by rho 1. In this inequality, uh, I can divide all the terms by a constant, by a positive non-zero number, and the inequality will be same. If we have, this is a concept of, this is a mathematical concept of inequality. If x and y are some, let's say if x and y are some positive numbers, and we have x less than y, I can always divide row less than, yes, if this is so, I can always multiply this inequality. I can always multiply both the terms, that is x and y, with some non-zero positive quantity, and the inequality will be same. So if k is a positive non-zero, is k is a positive number quantity, a positive real number, I will have kx is less than ky. So conversely, if, so this implies x less than y, where x and y are some positive numbers, implies k into x is less than k into y, where k is a positive number. Also, if we have k x less than ky, I can divide both sides. Since k is a positive number, I can have, say that x is less than y. So applying this concept, I can say that 1 by rho 3 is less than 1 by rho 2 is less than 1 by rho 1, because in this inequality there is a constant factor of rho in all the terms. So if I divide all the terms by rho, I will get 1 by rho 3 less than 1 by rho 2 less than 1 by rho 1. Now if I take the inverse, if x and y are two positive numbers, and if we have x greater than y, this will imply that 1 by x is less than 1 by y. Similarly, x less than y will imply 1 by x is greater than 1 by y. So from this fact, I can clearly now say that rho 3 will be greater than rho 2, this will be greater than rho 1. So, or rho 1 is less than rho 2 is less than rho 3. So the correct choice is A. A is the correct choice. Question 5 is also, I'm sorry, there is no description. Actually, in question 5, what we are having is the liquid is same, since the density is rho, it is same, but we are seeing that the body are having different densities, rho 1, rho 2 and rho 3. Rho 1, rho 2 and rho 3, and it is from the first figure, it is in the first figure the body is floating, partially immersed. In the second figure, the body is floating, fully immersed, and in the third figure, the body is also floating, partially immersed, but the immersed part of the body is greater than the immersed part of the body in the case 1. So again we have to, now we have to say compare rho 1, rho 2 and rho 3. Okay. Now what can we say? Okay, clearly, since in the second figure the body is floating but fully immersed, I can clearly have rho 2 is equal to rho, because when the density of the body is equal to the density of the liquid, we know it floats fully immersed. Okay. For the for the first figure, we can clearly see that uh, also in this figure, also in this figure, the volume of the all the three bodies are is same. This should also be a this is also a fact, part of the problem. The volume of all the bodies are same. Mm, no, I don't think the volume of the bodies need to be same. They can be of any volume. What eventually will matter is the fractional part. I mean, the immersed part of the body when it is floating. How much? What? I mean, how much part of the whole body is the immersed part? That fraction uh, will matter, and that fraction is definitely not dependent on the volume of the body. It is only dependent on the relative densities of the body and the liquid. So, from the figure 1, if I consider that F1, the fraction of the body immersed in the liquid is F1, so F1 will be equal to rho 1 by rho. Okay, and let's say for the case 3, figure 3, let's say F3 is the fraction, that is if F3 fractional part of the body is immersed in the liquid, so F3 should be equal to rho 3 by rho. Clearly from the figure we can clearly see that F3 is greater than F1. Visually we can clearly see that F3 is greater than F1. So this implies that rho 1 by rho is greater than sorry F3 is rho 3 by rho is greater than rho 1 by rho. This implies that we can multiply both the, in this inequality we can multiply both the terms with rho, and rho is a positive constant and the inequality will remain the same. So from here we can say rho 3 is greater than rho 1. Clearly rho 3 has to be greater than rho 1. Now, so at this stage, that is rho 1 is less than rho 3. Okay. Also note that, so we got a relation between rho 1 and rho 3. What about rho 2? How do we compare rho 1 with rho 2 or rho 3 with rho 3 with rho 2? Since all the bodies are floating, the density of the body has to be less than equal to the density of the liquid. So clearly rho 1 is less than rho. Also rho 2 is less than rho rho 3. Since rho 1 and rho 3 are floating in the liquid, partially immersed, so definitely rho 1 is less than rho and rho 3 is less than rho. So this will and we know that rho 2 is equal to rho. So this implies rho 1 has to be less than rho 2 and rho 3 has to be less than rho 2. Also we know that rho 1 is less than rho 3. So all these three facts, from these three facts we can clearly see what we will have. We will have what we will have. we will have mm, rho 1 and rho 3 are less than rho 2 and rho 1 is less than rho 3. So clearly we will have rho 1 less than rho 3 is less than rho 2. This should be the correct ordering, and I gave the choices incorrectly. This choice is not given in the 4 choices. So this is my mistake. This should be the ordering of rho 1, rho 3 and rho 2. Now if I did any kind of mistake while solving the problem, applying the concepts that I have discussed, or did any kind of silly mistake, then please feel free to let me know in the comment section. I will highly appreciate that. So with this, it brings to an end in solving another 5 multiple choice questions on the topic of sinking and floating of a solid in a liquid. I think there is no other topic left from this chapter of physical quantities and measurements. I will see if there is. I will make videos on those subtopics, but I do not think there is any other topic that has numerical problems. So if there is no other topic, I will move on to the next chapter, which I actually do not know. I will see. I will move on to the next chapter. So if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Stay tuned for the upcoming videos, and I will end the video here. Thanks for watching, and until the next video, take care and bye.